Okay, so we have here another problem. In this time, we can see that we have a block rotating around point O. So we have that the 5 kilogram block is rotating with a constant speed of 2 meters per second around the circular path center at O on the smooth horizontal plane. So right away we know that because it's smooth, there's no friction. If a constant tangential force F of 5 newtons is applied to the block, determine its speed when the time is equal to 3 seconds. Neglect the size of the block. So let's write down all the givens. So we have here the mass, it's equals to 5 kilograms. We have velocity 1 is equals to 2 meters per second. We have there's a constant tangential force of 5 newtons. This we gotta look for the velocity after 3 seconds. And we have a radius of curvature, you see from here, of 1.5 meters. And once again, we are looking for velocity 2. So using the equation for the angular momentum and impulse, we're going to have then that the angular momentum at state 1 plus the sum of the impulses, from t1 to t2 with the integral of the moments of a point O with respect to time, it's equals to the angular momentum at state 2. So that's all we have to figure out for this problem. So we can replace the stuff, we know what they are, right? And that way we are able to calculate this stuff. So if we rewrite that equation, the angular momentum, once again, that is appears to be constant, right? We don't have any variable forces, we don't have anything variable, so we can write the scalar version once again, where we have that the angular momentum is just a distance times a force times a change in time. Or we can use the other definition where this is also equals to it's the same radius, so the same radius of over here times momentum. So it could be a force times distance, a force times time. So this could be R times NV, right? Where of course our R will be our radius of curvature for this problem. So if we rewrite the whole equation, then this will be the radius of curvature, that's our perpendicular distance, times the momentum at state 1, plus the sum of impulses from T1 to T2. This will be R cross product some force dt. That is basically the definition of momentum. I think this is the definition over here for momentum right there. All right, for a moment, I mean. And then we have this is equals to rho mass v2. Okay, so we have everything here, everything set up. So we just plug in chug for this one. So we know the radius of curvature is 1.5 meters. We know the mass is 5 kilograms. We know velocity 1 is 2 meters per second. Plus the only force acting is tangential force given right there. So this is the integral from 0 to 3 seconds of our radius. So that is 1.5 meters times 5 newtons dt. And it is equals to 1.5 meters times the 5 kilograms V2. So once we multiply everything here, we should obtain 15 plus 7.5 t evaluated from 0 to 3 equals to 7.5 V2. And once you evaluate all of this stuff, right, you are going to get 15 plus 7.5 times 3 minus 0 equals to 7.5 V2. Solving around for V2, you should get that V2 it's equals to 5 meters per second. So once again, we've done these problems before, they're pretty straightforward, but this time they're done, instead of moving in a line, we're moving in a curvilinear fashion. So we use the principle of angular momentum and impulse, but we have done these problems already before. Okay, so let's do one more problem on this, and that should be it for this topic. Okay, so in this problem, we have two identical 10 kilogram spheres that are attached to the light rigid rod, as you can see in the picture, and they rotate in the horizontal plane centered at pin O. If the spheres are subjected to a tangential force P equals to 10 newtons, and the rod is subjected to a couple moment where the moment is equals to AT, notice that is a function of time, determine the speed of the spheres at the instant when the time is equal to 4 seconds. Notice also the system starts from rest, and we have to neglect the size of the spheres. And notice the distance from the spheres to point O, that is 0.5 meters. So let's write down the givens. So we have the mass of the spheres are 10 kilograms for each sphere. The force acting on the spheres, it's 10 newtons. We know the moment, or the couple moment given right there, is a function of time, AT, in Newton meters. We have velocity 1 is 0 because they start from rest, so 0 meters per second. We have to find this at time equals to 4 seconds. And notice also here, our distance r is equals to half a meter. And we are looking once again for V2. So we're gonna do a pretty similar approach like we did before. Notice that because my initial velocity is 0, right? Then my angular momentum at the beginning would also be 0. So this simplifies a little bit more the stuff. All right, so let's start writing down then those moments or those impulses that we can find here. So we have the moment arm that's done by the force about point O, so that is 10 kilograms. Okay, so let's find the impulses or the moments that we can have in this system. So notice we're gonna do the one about that's being caused by the force acting perpendicular to the moment arm. So we're gonna have here then, this is 10 kilograms times 0.5 meters. Or I mean, not 10 newtons, sorry. This is not 10 newton, this is the 10 newton force acting there, not the 10 kilograms. This is a 10 newton force times the 0.5 meters, right, times 4. Because this is the 4 seconds that it takes, right? So it's the 4 times the distance times the time. That is, we set out how we find a moment in scalar form. And we multiply this times 2, because there's 2 spheres that are doing the same moment arm. So the 10 newton force times the moment arm of half a meter times the 4 seconds that they act on, that's for the impulse, times 2 because there's 2 of those spheres. If there was more spheres, you will multiply that times more. And then plus the integral of the variable moment right there. So integral of AT dt evaluated from 0 to 4. And this is equals then to, over here will be the radius, so that will be 0.5 meters, or the angular momentum, times the 10 kilograms times V2, and this will be also times 2 because there's 2 of those spheres. So if we're bringing things from here, we are going to get, this is 40 plus 4t squared evaluated from 0 to 4 equals to 10 V2. So it's just a matter of then substituting in the values, solving, rearranging, and we should get out of here that V2 it's then equals to 10.4 meters per second. This is the velocity that it attains, after this system starts to rotate after 4 seconds. So notice the principle is pretty straightforward. Once again, we've done this before. It's just we're doing this for curvilinear motion or rotating motion as opposed to linear motion, but it is the exact same process. So that is it on the angular impulse and momentum, and then the next videos will focus on the collision stuff. All right, if you have any more questions, you guys can see the other problems in the book or in the notes, or you can, let me know by email. Until then, good luck, guys.